All right, welcome back, students. Now we're looking at the paper from 0580, Extended Mathematics. We're looking at series May, June 2020, paper 2, variant to 1. We have done part 1, and if you've missed the part 1, go and click on from the playlist and catch up on part 1. Now we are going to look at part 2, where we will try to cover question 6 to question 10. Now, let's move on. Question 6. The diagram shows a trapezium. And then, if you look at the diagram carefully, there are 2 arrows, and that arrows significantly play an important role in this, where they are parallel. And when they are parallel, we know that there are 3 angles that is really important and really helpful to us. One is alternate angles, that's the one I've stated here. And of course, there's another one that we call them corresponding angles. And then there's another one, which is the one that I stated here, co-interior angles. All right, so now for corresponding angle, sometimes we call them as an F angle because they have the F shape, and then the angle that is along the same position of the parallel line would be equal. And then for the alternate angle, sometimes we call them a Z angle, where the alternate angles are equal. For co-interior angle, it is not equal, but on the contrary, what they do is the 2 angles will add up to 180, or they are actually supplementary to each other, making up into a straight line. Now, work out the value of x. Okay, I have suggested 2 perspectives of looking into this. The first one is the one that I colored in purple, where you notice that this is a C diagram, or we call them the co-interior. Now, co-interior, these 2 add up supposed to be 100. Therefore, if you take the 97 minus 3x plus the 69 plus 5x, that's how you sum up to 180. Then carefully remove the brackets, simplify, and then solving it, you arrive at x equals to 7. And if you take another alternative method, I use in alternate angles, the one that I highlight with green color, you notice that it is an Z shape. And then we notice that this angle and these angles are equal. Therefore, when these 2 put together, you notice this is going to be a straight line diagram. Okay, a straight line angle. Therefore, when you put in 97 minus 3x plus 69 5x, that equals to 180. You do the same thing, rearrange, and until you simplify to 7 degrees. Then you notice that both methods arrive at the same answer. Okay, so now let's look at question number 7. They give to us 234 equals the 2 times 3 squared times 13. This is the list of the product of the prime factor for 234. Then you notice, okay, this number will be able to break up to its product of its prime factor. 1872 will be able to break up to its product of prime number in that manner. Then they also give to us 234 multiply 1872 will equal 438048. Now they say use this information to write 438048 as a product of its prime factor. So now let's take a careful look. 234. multiply 1872, we know that that's going to equal to this. But we also know that this thing can be derived into its products of factor, the one that you have already break it down. Then now the same thing you notice for 1872 also already have its products of prime listed down to you, and that will equal to 438048. So now, once you list it down, the next thing will be super easy. What you just have to do is looking up for the same bases and then play some indice rules, right? With some indice rule, okay, that you know when A multiply a number with A to the power of another number, you know that there's going to be X plus Y as long as their base is equal. So now, if you look at here, you gather all the base which is the same, then the one that did not write are actually having power of 1, power of 1. Those that did not write is actually having power of 1. Now you gather the base 2, you get power of 1 plus 4. There you go. And multiply base of 3, you got 2 plus 2. There you go. Then base of 13, you got 1 plus 1. That's it. Then now, by sum them up, 2 to the power of 5, 3 to the power of 4, and then 13 to the power of 2. And that's it. You got your answer and list it down in the answer column. Now we go to question 8. We're going to look at somehow this kind of a very familiar question. We have been seeing this a lot of time. Okay, without using a calculator, work out mixed number 2 and 1/3 minus 7/8. Both of these are being bracketed in. Multiply 6/25. Now, well, the first thing we need to do is converting the mixed number to improper fraction. Okay, so how do we convert? We just take 3, multiply 2, to multiply here, and then you add on 1, and that's how you get 7. Okay, then we go to the next things to do is making both of them the subtraction with the same denominator. All right, that's what we do. We cross multiply the 3 and the 8, and then we multiply the same thing at the numerator. Now, both of them share the same denominator. Simplify them first, those in the bracket. That is the third point. Okay, work out the bracketed item first. The bracket item first. There you go. So once you get that, then you go to simplify with the multiplication, and then you multiply, then you work on the multiplication, and then simplify. There you go. So you got the final answer, 7/20. Okay, question number 9, factorize completely. All right, so one of the common and easy way to look at that is just to take nothing for granted. I just want to show the some of the common way how do we do this. Okay, what we do is we take each of them, the 2 terms there. Okay, the factor means we're going to put a bracket. All right, we're going to put a bracket. What is the bracket? All right, bracket will contain of the 2 separate terms. In this case, let's take a look at that is a plus I'm going to put a, okay, there's a plus, so we're going to put a plus there. Then there must be some kind of a purple item here, and then there's also a green item here. And then what's in front? What are we supposed to put in front? The front supposed to be the common factor that's shared by both of this term. Now, okay, that is the general idea. Let's take the 21a square and break them down to their factor. 21 can be made by 7 times 3 times a, and that gives you 21a square. Then for 28, you can get that by 7 times 4 times a times b. All right. Now you have got all the factors listed down. And what you do is look out for the common factor. Who are they? Common factor, all right, between the purple and the green, yes, both of them share 7. And what other factors that they share? They share the 4. All right, now these are the factors that you're going to put in the front, where you're going to have 7a. Now you got that, and you're going to open up the bracket. This is where you're going to put in what are the the remaining, right? The remaining factor for the purple. What are the remaining term do you have? It is there's a 3 and a. So now you're going to put in 3a there. And what about the green term? You have 4 and B here. If you carefully look at that, there is a 4 and there's a B that is still left behind. So we're going to put that for B. And that's now, you notice that you have a common factor that I'm going to highlight here. This is what you have, common factor. This one, common factor. And then the purple term, now you have 3a, and then the green term, now you have 4b. And that's explain how we get this answer. And there you go. Now we go to part B. It is very, very interesting. You notice we are still able to use a kind of a similar idea. But now we got, so if you notice the 20 and 45. Okay, what is the common factor between 20 and 45? That's why you know. Yes, you're right. You notice that 5 is the common factor. That's why you have done that, common factor 5. Then now the remainder. By doing that, you know that you're going to pull out 4 and x squared. All right, using the similar way of working up here, you're able to find that you have 4x and then minus 5 times 9 to get 45. So that's how you get that. Then by doing this, you notice there is something very interesting that we can further factorizing them. All right, so now you notice there are perfect square. All right, so the common factor is already settled. Let's get it down. Yeah, let's let them all laid out. Then you notice that both of these are they are all perfect square. Okay, perfect square, where you know that you can, using the index rule, 4 derived from 2 square, and then 2 square x square, you can bracket them out into 2 square, both of them power of 2. So you do the same thing for 9y square, getting to here and getting to here. Take your time going through and you see how we simplify them and bracket the 2 perfect square terms. Now, when you notice that this is a term, we call them difference of, all right, this is let me write it down here. This is different. This is, let me put a similar color. This is, let me write it down here. Different of two square. Okay, and difference of two squares, which let's say if I put in a square, perfect square A minus perfect square B, I can simplify them into both of the AB. I will do it down, just copy that. Then the next thing you will notice, very, very easy, 1 plus another minus. That's it. So you can, if you memorize and you do the practices, you will know that this has been some formula that has been coming up quite often. So by doing that, you see that the 2x is the perfect square. So that's why now I'm going to put the 2x, and I'm going to underline this 2x squared, and then here the 3y squared. That's how we take the 3y, and then the 2x. If you notice that the only difference that we do is we just put the opposite sign between them. Yeah, okay, so that's how we get the square. Now we come to the last question of our part 2 video. Okay, this is under the topic of circle theorem. Yeah, let's put in there, circle theorem. And you wanted to do revision, just type in circle theorem or go to your textbook, look up for circle theorem. Okay, now read the question. Points A, B, C, D, E, and F lie on the circle, center O. Find the value of X and the value of Y. Okay, now we're going to take a look and study where is the X and where's the Y. Okay, if you look at the X, where is it? All right, if you notice X is here, and then, so by circle theorem, did showed us that the X, what will help you is to look at the 2 feet, the feet where that angle springing up from, or in normal when we say that is the arc, right? So we notice that X coming up from this 2 point, right? That's how X is formed. And then you maintain this 2 point and then see whether is there any other line that projected out of it. Yes, you saw that, and the angle is 110. And then you notice the 110 is at the center of the angle, and that gives us from the circle theorem that the angle at the circumference is half the angle at the center. That's how, by noting this, that's why I put in the 2 arrow there, that this X, which is the angle on the circumference, is half the angle of the one in the center. Therefore, X, which is the one in the circumference, is half the one in the center. So you take half, multiply 110, and that's comfortably getting X equals to 55. Done. Now we go to see Y. Using the similar idea of working, all right, look out for where Y is. Then you, without much difficulty, I believe you know that Y is here. Then what you do is you look at the 2 hands, that join together that make the Y. When you saw the 2 hands, what you do is you look at where they're springing from. All right, so then when you see that, and then you take from the same feet, you see whether do they spring up to form another. Yeah, they do. So when you see that, then you see this is a 24 which is given to us, and then based on the circle theorem, they also says that angle of the same segment, that means the angle that is springing up from the same segment are equal. Therefore, this is 24, y will also be 24. Yeah, so by doing that, you were able to quite comfortably getting the answer of y equals to 24. So this is the we have done, and we're going to take a break from part 2. Okay, and then we will come back again for part 3 from questions 11 onwards. All right, so it's exciting to see you again in part 3. Go, if you did not watch part 1, go and take a click onto it and watch it. All right, so take a good break. I'll see you real soon for part 3. See you. Bye.